All right, so we are going to go over another example for related rates. This one has to do with concentric circles. Okay, so just circles that are kind of found inside of each other, kind of like ripples, right? Whenever you throw a rock into water, you kind of see these circles forming over and over again, right? So, um, this is what the problem reads in your book. Okay, later on we're going to do other problems that are not in your book, but I kind of like going over the stuff that's in your book first, so that when you look at the homework from the book, it kind of makes sense to what you learn. Then you're going to get a worksheet later from me, which is going to have a whole different set of problems. But here's the question from your book. So let me put example number 1. And we'll write down things that are that they're mentioning here, then we'll highlight some stuff. Okay, so it says a pebble is dropped into a calm pond. So a pebble is dropped into a calm pond. Next. And it causes ripples to form. So causing ripples to form. Now again, these ripples are going to be circular. Okay, I mean, as you should expect from it, but they're going to be circular. The radius r of the outer ripple is increasing at a constant rate it's increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total? What rate is the total? I think it's area. Yeah, area A of the disturbed water changing. So this is one problem. So I'll kind of give you a minute or so to kind of finish writing this out. I'm going to kind of pause the video so people aren't just watching nothing happen. So I'm going to pause real quick. All right, so the fact that the pebble is dropped into a calm pond would be important if we were trying to figure out like free fall information, but we're not. We're talking about related rates. It causes ripples to form. Now, of course, knowing that the ripples are circular is important. I know they don't tell you that, but that's something you guys should be able to kind of figure out. They're not trying to be super obvious about things, but this is a circle, right? They say the radius r of the outer ripple is increasing at a constant rate of 1 foot per second. So when they say that the radius of the outer ripple is increasing at a rate of 1 foot per second. So they mentioned rate. They mentioned 1 foot per second. Now, what does rate mean? Well, rate of change, but what is it? What do I have to do to find rate? A derivative, right? So rate means take a derivative. A derivative of what? Read the sentence before the word rate. The radius, right? The radius, r, is increasing at a constant rate. Now, the fact that they said it's increasing means that the value is going to be positive. Okay? Notice that the derivative of r with respect to time is dr dt. Okay, so they're saying the rate at which the radius is increasing is 1 foot per second. Notice the measurements are in terms of velocity, right? Foot per second, meters per second, stuff like that. And the reason is because the position of the radius would just be r, so the derivative of the radius is going to be its normal measurement, feet, over time, right? So it becomes kind of like a velocity. Again, it's increasing, so it's going to be a positive 1. Okay, so that first sentence, or second sentence, I'm sorry, gives me information about dr dt. Okay, so they said the radius is increasing at a rate. So dr dt of 1 foot per second, so I just put equals to 1. They say when the radius is 4 feet, at what rate is the total area A of the disturbed water changing? So at what rate is A changing? Okay, so they mentioned when the radius is 4 feet, what rate is A changing? Well, they said area, right? I could probably highlight that too, just so you know. They want to know at what rate is the area changing. So the area of a circle, right? When they say the rate of the area, they don't just want A. What do they want? They say the rate of the area. How do I write that? dA over dt, right? The area over time. The area is going to be changing over time. So what they want to know is, what is dA dt when r equals 4? That's the main question. What is dA dt when r equals 4? Because they said that when the radius is 4 feet, what is the rate of the total area? Or what is the rate that the total area of disturbed water is changing? So what formula do I use for area? Well, it's a circle. So pi r squared, right? So there you go. I got to take a derivative of this. So let's do that. The derivative of A is 1 dA dt. Right? So dA dt is equal to, pi is a constant, so I can just leave it out here. The derivative of r squared is 2r dr dt. So the rate of change of the area is its circumference times the rate of change of the radius. Okay? So, all right, here is my derivative for dA dt. Now that's what they want me to solve for, right? dA dt, that's the main question. What is the rate of change of the area? So all I have to do is plug in an r value and plug in whatever dr dt is. Okay, by the way, never plug in numbers to begin this problem. So in other words, don't plug in a number like right here, say, oh, they said when r equals 4, let me plug it in. Because in that case, all you're going to have is a constant, and then when you take a derivative of it, you're just going to get 0. Okay, don't ever plug in numbers to begin a problem. Always wait till after. The only time you can really do that is if they tell you that something is not changing, or if you know something is not changing. So for example, if the radius of a cylinder is 5, you can probably plug that in right away because it's not going to change over time. It's a cylinder, so it's going to keep its same radius. But if something like a cone that has a radius that changes at all times, then for that one you don't want to plug anything in until you're ready. So anyway, we're right here at dA dt. When r equals 4 will be 2 pi times 4 times dr dt, that's 1. So my answer is 8 pi. Now, I gotta put the right units. So what's the units for area? A squared, so it's feet squared over time, which for us it was seconds. So there's my answer to this problem. So the rate of change of the area is 8 pi square feet per second when the radius equaled 4. Go ahead. Oh, that was given right here. Remember in the very beginning of the problem, they said that the rate of change of the radius the radius r was increasing at a rate of 1 foot per second. So that was just a given. So I'm kind of looking at the information that's given to me, and I highlight things, right, just to kind of give myself an idea of like, okay, they're talking about the radius, and say it's increasing, that means its value is probably going to be positive. They mention the word rate, which means it's probably a derivative. Then they give me a value, right? That value, foot per second, that means that has to be some kind of measurement over time, so dr dt. When I read the second or the third sentence there, it says when the radius is 4, okay, so when r equals 4, what rate is the total area A changing? So the rate of change, right? Rate of change. They're not specifically saying it, but rate of change means derivative. So I have to take the derivative of the area with respect to time and solve for it when r equals to 4. Okay? So that's kind of what I had to go through in order to find this answer. This is, again, another problem that's a rate of change problem, or related rates. So any questions on this one before we go into a sphere?
How come it's dr dt when you get the derivative?
The 2r part?
Yeah.
Because remember, we're doing all this with respect to time, right? So with respect to time, you got to be taking derivatives of t values. But since I took a derivative of a, then I got to say dA dt. Since I took a derivative of r, I got to do dr dt. If it would have been a derivative of t, I would never write that. But it's with respect to time. Any other questions? All right, so let's do example number 2 here. So air is being pumped into a spherical balloon. So air is being pumped into a spherical balloon. At a rate of 4.5. So notice there's a keyword right there, rate of 4.5 cubic feet per minute. I want to abbreviate, but I want to leave it the way they wrote it. I'd rather just write cubic feet per minute in abbreviation, but sometimes it's good to see them write it out, because sometimes they'll say like per minute, meaning minute squared. So just trying to keep it consistent to what they have. Find the rate of change of the radius rate of change of the radius when the radius is 2 feet. I'm going to go ahead and pause real quick and then we'll be right back. All right, so let's get started with this. So air is being pumped into a spherical balloon at a rate, so here's a keyword, rate of 4.5 cubic feet per minute. So notice I'm going to kind of use two different colors here for this one, just because this is actually very important. They don't really tell you what 4.5 belongs to in a very specific way, but if you look at its units, what is 4.5? They say cubic feet per minute. What is cubic feet represent? Volume, right? Per minute is over time, right? So they are giving me, and then they said rate, right? Rate means derivative. So dV dt is 4.5 cubic feet per minute. That's what that first sentence just gave me. They said volume is changing, right? And then you got to think about that. If you're pumping air into a balloon, it's getting bigger and bigger, right? So you can tell the volume's expanding. They're telling us that 4.5 cubic feet per minute is my unit. Cubic feet means volume, minute means time, so it's V over T. They mentioned rate, so it must be dV over dt. Okay? So just kind of looking at some of the key terms that they said in the first sentence. Second sentence, find the rate of change. Now again, rate of change is very important. That means derivative. Okay? So you're going to be taking a derivative. Derivative of what? Find the rate of change of the radius. Okay? So I can highlight all this. The rate of change of the radius when the radius is 2 feet. So the way I write that out, the rate of change of the radius is going to be dr dt. They want me to find the rate of change of the radius when the radius is 2 feet. That's my objective. Find dr dt when r equals 2. Okay? I know dV dt, that's 4.5 cubic feet per minute. Okay? But I don't know dr dt yet. So what's my formula for a sphere? Anybody? I'll start real slowly. No? Alright. Nope, nobody? Alright, there we go. That's your formula for a sphere. V equals 4/3 pi r cubed. That's why I gave you guys that 35-page thing. Okay, that's page 2 if I'm correct. Let me see. Let me double check, but pretty sure it's page 2. Yep, right there. Page 2, second from the bottom on the right. So anyway, let's take a derivative. So derivative of V is 1 dV dt equal to 4/3 pi, because that's just a constant. The derivative of r cubed is 3r squared dr dt. Now remember, I'm supposed to be solving for dr dt. So I'm going to get rid of this 3 here and this 3 there. So if I clean this up a bit, I get dV dt is equal to 4 pi r squared dr dt. So to solve for dr dt, I'm going to have to divide both sides by 4 pi r squared. So I'm going to do that. I'm also going to flip my equation because I'm a little OCD about that stuff, okay? So dr dt will be dV dt divided by 4 pi r squared. That's what dV dt is. Sorry, not dr dt, not dV dt. That's what my dr dt is equal to. So it's dV dt divided by 4 pi r squared. Now, they want me to figure out dr dt when r is what? 2, right? So dr dt when r equals 2 is, what is dV dt? 4.5. Okay, 4.5. 4 times pi times r, which is 2 squared. So this is just going to be 4.5 divided by, that's 2 squared, 416 pi. And 4.5 divided by 16 pi, that's equal to, I don't know if I even wrote my answer here for this. Let me check. 0.09, is that as far as they went? I don't really like that, but let me double check. That's as far as they went. So 0.09. What's my unit for this? Well, let me give you a hint. Radius over time. So how do you measure the radius? Just feet. And time is, what was this in seconds? Minutes? Okay. So there you go. Your derivative should tell you what your units are. Okay? So pay close attention to your derivative so that you know what you're going to be labeling stuff. Units are very important. Don't include units. You usually don't get points. Okay? Because they need to know what is it that you solve for. Volume, area, distance, like what exactly are you doing? The units give us a lot of information. Any questions on this one? I mean, here's the whole thing, right? Of course, I work vertically, so it looks a lot worse. But anybody have any questions on the work for this one? So just make sure that you're able to take your derivatives, okay? Make sure that you do your implicit differentiation correctly, right? You don't want to mess up and leave out like a dr dt or a dv dt or something that's going to be important. But you always got to make sure that everything's kind of working out right. So don't rush through these things. Take your time, okay? Right? It's more of a marathon than it is a sprint. The only time it's a sprint is when you're taking your test, when it's 3 hours in your time. Then you got to run, okay? But for your homework, make sure you understand it and you're trying the best you can on it. All right, let me see if I can get one more in here if there are no questions. Let's see. All right. Example 3. I think I have to draw a picture for you guys here, but let's see. An airplane is flying on a flight path. An airplane is flying on a flight path. That will take it directly over a radar tracking station. It's going to take it directly over a radar tracking station. Right here it says, as shown in the picture, so I'm probably going to have to draw a picture for you guys. It says, if S is decreasing at a rate of 400 miles per hour, miles per hour. Let me write it out like they did. When S equals 10 miles, what is the speed of the plane? All right, so let me draw a picture. as you guys are kind of writing stuff out. So they have a little house with the radar on top of it. And that's measuring where the airplane is. So forgive my airplane drawing skills. We'll make it almost like a stealth fighter. There you go. There you go. More like a bird. So again, I'm just drawing the picture they have in the book. They did mention in this picture that this height is 6 miles. They also labeled this S and this X. They have some trees. There you go. Maybe that makes it more believable. I don't know why, but there you go. With black trunks. But anyway, so yeah, they have everything all drawn out. There's mountains, etc. Okay, so there I'm just trying to kill some time while you guys finish writing your sentences. If you can't see it, you gotta use your imagination. Let's give them a door so they can exit at least. Maybe a window to look out of. All right, everybody good writing this down? Anybody still writing down the big problem? All right. 6 miles. Yeah, I think my pen just dragged. Miles. M-I. It's 6 months up. Yes, 6 miles. If I zoom in enough, it's almost like you're there. No COVID there. Mask not required. It's there. Don't you see it? It's white. All right. Now these are more like hills. So anyway, let's get to it. It says an airplane is flying on a flight path that would take it directly over a radar tracking station. If S is decreasing at a rate of 400 miles per hour, so let's look at some information here. They say S decreasing rate of 400 miles per hour. So what did they just give me? How can I write that mathematically? All right, ds dt equals how much? Almost right, but very close. Well, that's even closer, but still something's wrong. Negative, because it's decreasing, right? Again, the word, I did highlight that. I thought maybe I didn't. But yeah, I highlighted it because it's important that you know increasing, usually positive, decreasing, usually negative. Left is usually negative. Right is usually positive. Up is positive. Down is negative, right? So pay attention to direction because a lot of times it's going to give you a hint as to what the numbers are going to do. Now, they say if S is decreasing at a rate of 400 miles per hour when S equals to 10. So actually, I could be a little bit more exact with this. When S equals 10. So I'm going to put a little S equals 10 right near the bottom, right there. So they said the rate at which that distance is closing in when S equals 10 is negative 400 miles per hour. What is the speed of the plane? What variable will tell me speed? There's only one left. X, right? Vehicle moves along the X axis according to this picture, right? It's flying. They say it's flying directly over, right? So straight across. So X is its horizontal movement, correct? So dx dt would represent its velocity, right? Because feet become feet per minute or feet per second, right? The first derivative makes it velocity. Always. Now you can think of the first derivative many different ways. It can be velocity, maximums, minimums, optimums. There's a lot of different things. But one of those things is velocity. So if x is its horizontal motion, then dx dt would be the velocity of the plane. So they want to know, what is the speed of the plane? And we're going to put at when s equals 10, right? That's what we're trying to figure out. So, what equation should I use? This isn't a circle. The Pythagorean theorem. It's a triangle, right? So, we know this is a 90-degree angle, mostly because of the fact that they mentioned that this airplane was going to take it directly over, which means there is no turbulence, there is no wind resistance. Math likes to deal with word problems as if we lived in a perfect world where wind did not exist. Okay? Physics says that's crazy. There's tons of air friction, there's wind resistance, there's turbulence, there's hot pockets, not the ones you eat, but the ones you can fly through, okay? And all these things that will affect your flight. And math people say, well, yeah, that's true, but theoretically, this is what should happen, right? You guys deal with what's actually going to happen. We're going to tell you what should happen in a perfect world, okay? That's why math, whenever I tell people I'm a math teacher, they look at me and they're like, oh man, that's crazy. And I'm like, you think I'm crazy? You should see the physicists, right? They're the ones that make those problems even harder, right? We make them easy. They'd like to make it even more difficult. So anyway, we want to figure out dx dt. We're going to use the Pythagorean theorem. So here we go. Now, I'm just going to write it out first, okay? Now, that's what we normally have. Now, for us, if a number is never going to change, we can utilize it, okay? And actually, let me not use r. I just realized it should be s, okay? Because s is my hypotenuse. So, I can actually plug in the 6 for my y value because it's not changing. They say it's flying directly. It's not going up and down or anything like that. It is always going to be 6 miles. If it wasn't, they would have mentioned it. They would have said, oh, as it approaches, the height starts to go down or goes up or whatever. They didn't mention any of that. So I am going to make the assumption that the airplane stays at a consistent height of 6 miles above that radar station. Okay? So since that's the case, I'm going to put that in. Only when a value is constant and never going to change can you ever do this. Okay? Other than that, you don't plug it in. I'll show you what it looks like if you weren't sure. If you're not sure if you should plug it in, I'll show you what it looks like in a bit, okay? But let's go ahead and take this derivative. So what do I get right here? X squared becomes, all right, 2x dx dt. What happens to 36? 0. And the s squared? All right, ds dt. All right. Now, I got to solve for dx dt, right? So I'm going to divide by 2x on both sides. So dx dt is equal to s over x ds dt. So, no, not my sprinklers. So, oh, I don't know. Do you have a question or just stretching?
No, I'm stretching.
Okay, I saw the hand, but I didn't know. So what I'm going to do now is I'm going to go ahead and plug in my information. So dx dt when s equals 10 is 10 over ds dt we were told was how much? Negative 400. The only thing I don't know is what? I don't know x, right? But check it out. We know this is 6, and we know that's 10. According to the information that I'm trying to figure out, right? When s equals 10, right? We knew that that one of the sides was a 6, the other side was x, so x squared plus 36 equals 100. X squared equals 64. So x is plus or minus 8. Well, distance can't be negative, so 8 goes there. Okay, so when I simplify that, I get negative 500. What are my units? Miles per hour, right? Miles, I'm going to put mph. Miles per hour. And that's my answer. That's how fast the airplane is going. Now if you're thinking, wait a minute, that's not very fast, that's a negative, right? Well, mathematically it makes sense. It tells me direction. Is the airplane moving left according to the picture I drew? Yes. So negative means it's going to the left. Or down, but according to the story, this is not crashing, it's flying, right? So it's going left at 500 miles per hour. So you could even write a sentence and keep it as a positive number. You can say the velocity of the plane is 500 miles per hour while traveling west. So there, that's negative 500. By saying the word west, now it's negative. Okay? Some people will argue that velocity should never be negative. Well, that's true if you write a sentence. Yeah, that's true. You can always mention positive or negative based on words. So you can always just have your number as a positive value. But if you don't want to use a sentence, which you should always pretty much use a sentence when it comes to AP exams and stuff like that, always to kind of clarify what your answer means. But you always want to make sure you mention it somehow in words. Okay? Now, I'm not going to be able to show you guys how this problem would fix itself if you didn't plug in that 6 miles, but I'll do it tomorrow. Okay? So tomorrow I'll show you guys what it would look like. But today we're running short on time. I think we got like 2 minutes. So, any questions before I stop this thing here? All right.